Chapter 1.7, Solving Equations in One Variable. Our target is I can solve linear equations. We're going to start out with some vocabulary that we're going to use throughout the year. The first one is open sentence. When we talk about an open sentence, we're talking about an equation or inequality with at least one variable. Okay. The next word or phrase is solution set. And that's the set of all values that make an open sentence true. Then we have what we call the identity. Okay? An identity is an equation or inequality that is true for all values of the variable. In other words, it's always true no matter what number you put in for the variable. Okay? Then we have what's called the empty set, also known as the null set. And it is just what it says. It's a set with nothing in it. So this is when we have no, we have no solution. Okay, so that's when no value that we would put in would work. Okay, then we have some symbols that we wanted to know. We have the equal sign with the question mark, which is translated, are they equal? Then we have the three dots that look kind of like a triangle or pyramid, is translated or read therefore. And then of course you all should know this one, the not equal sign. So it's translated not equal. And then we have the 0 with the line through it, or brackets with nothing in it. And that is translated empty set or null set. All right. Now what we want to do today is just solve simple equations. So for instance, solve 3 times 2x minus 3 equals 4x plus 7. Now when we're solving equations, our goal is to get the variable on one side and everything else on the other side. So that's what we're working towards. So in this first one, the first thing I'd want to do is be to remove the parentheses, since I can't do anything in the parentheses. So I'm going to distribute the 3, so it gives me 6x minus 9 equals 4x plus 7. Then I want to move all my x's to the left-hand side, so I'm going to subtract 4x. That's going to leave me 2x minus 9 equals 7. Then I'm going to add 9 to both sides. Again, remember the goal here is to get your variable all by itself and everything else on the other side. I'm almost there, I just have to get rid of the 2. And so since this is multiplying, I do the opposite, which is dividing. So I get x equals 8. So the solution to this problem or equation is 8. 8 is the one value I can put in for x that makes the equation true. Okay, example 2. 3x minus the quantity x minus 5 equals 2 times the quantity x plus 4. Again, I want to solve this equation. That would be the directions. I look inside the parentheses, I can't do anything, so the next step is to remove parentheses. So on the left-hand side, I'm going to distribute the negative. On the right-hand side, I'm going to distribute the 2. On the left-hand side, I'm going to combine like terms. Then remember, our goal is to get all our x's on one side, everything else on the other side. So I'm going to subtract 2x from both sides. And when I do that, I get 5 equals 8. Now, does that make sense? Can 5 equal 8? It doesn't make sense. So whenever you get something like this that doesn't make sense, that means that there's no solution. There's no value for x that will make the equation true. So we would say our solution is the empty set or empty brackets. Okay. Example 3. So example 2 was the opposite of an identity, okay, because there's nothing that works for example 2. Example 3, we're going to see an example of an identity. Okay, so I progress just like I did before. So it's going to be 3x minus x plus 8 equals 2x plus 8. This is going to be 2x plus 8 equals 2x plus 8. Subtract 2x from both sides. We get 8 equals 8. Now in this case, 8 equals 8 makes sense. So that means that this is an identity. And so the solution is all real numbers. Any value I put in will work. Okay? Now, the last type of problem that we're going to look at is what's called a literal equation. So I want to solve this equation, k equals c plus ct, for t. Now notice that this equation is made up of all variables, but I only treat t as a variable. So I want to get t by itself and everything else on the other side. So I'm going to subtract c from both sides. I can't really subtract c from k, so I write that k minus c equals ct. Then I want to get t by itself. So to undo multiplication, I divide. And by symmetric, I can flip that over. T is equal to k minus c over c. So this is the solution for this literal equation in terms of t. Okay? And last example, a slightly more difficult example for a literal equation. Let me get some more room here. Okay, so I want to solve W equals AZ plus B divided by CZ plus D. I want to solve it for Z. So in other words, my goal is to get Z all by itself on one side. First step I have to do is put these in parentheses. Then I want to take this one and get it out of the denominator. So I'm going to multiply both sides of the equation by that parenthesis, CZ plus D on that side, and on this side, CZ plus D. I'm going to multiply times that. So what I get then is W times CZ plus D equals AZ plus B. All right? Then notice that I have a Z inside the parenthesis. I need to get that out of the parenthesis, so I have to distribute the W inside to get rid of the parentheses. So I get CZW plus DW equals AZ plus B. Okay? Again, keeping in mind that I'm trying to get all my Z's on one side and everything else on the other side. I am going to first subtract DW from both sides. So I get CZW equals AZ plus B minus DW. Now I want to move this AZ to the other side. So I'm going to subtract AZ from both sides. Well, that looks pretty ugly, doesn't it? Let me rewrite that, AZ. Okay? So I get CZW minus AZ equals B minus DW. Now what we're going to do is we're going to use the reverse of the distributive property, and we're going to factor out the Z. And we're going to get Z times CW minus A equals B minus DW. Now, to get Z all by itself, I want this all by itself, I just divide by the parenthesis. But if I do it to one side, I have to do it to both sides. So my final solution is Z is equal to B minus DW over CW minus A. So this is solved in terms of Z.